Thank you, Simon, and thank you, Meshwork, for the opportunity to present to everyone the benefits of working and building with straw. So, excuse me, who are we? We are Straw Bale Building UK. We're members of the European Straw Building Association and members of the British organisation, the Alliance of Sustainable Building Products. Could you go to the next slide, please? So we were founded in 2015. Our aim is to promote straw building and best practice. On the left-hand side, you'll see photos of some of the founder members of Straw Bale Building UK. Geoffrey Hart brought together a motley crew, if I could be so bold as to call it that, which included Eileen Sutherland, Mary Rawlinson, Phil Christopher, Jeffrey Neward, and many, many more, and myself, to really promote and develop straw bale building, which is what we initially decided to go with. Also in that room when we started was Roland Keeble from Ibukai. So we're not just focusing on straw, although that's what we're doing today. We also consider other bio-based materials too. And like I said, our intention was to promote straw building and best practice. And the best ways to do that is literally, hands-on. And it meant that to promote at conferences and to build properties and sites for our customers, because our membership consists of builders, practitioners, educators, and advocates such as myself. Next slide, please. So moving on from 2015, within that time and leading up to 2017, we were just working away behind the background, in the background. And along came this project called the Upstraw Project. It was a pan-European project, a Northwest European project. Some of the outcomes included building sites within Europe. And the main aim for the project was to promote straw building within the public sector. Out of that project came the technical guide, the straw EPD, and on the right-hand side, you will see the Bale House, which is the visitor centre in the Hastings National Park. We came together as a group, as a consortium, and rather funnily, we decided to call ourselves Constrawtium. Ha ha ha. Don't all laugh in the back. And it was a successful project, absolutely stunning, and credit goes to those who built it and formed it. So next slide, please. So in addition to building and promoting, we also hosted our own events. So in 2018, Geoffrey Hart gathered some of the main players within the industry, within the UK specifically, Down to Earth site in Swansea to build, or rather to build more the network and to promote the work that was going on. In 2019, we had ESBG. Now, ESBG is the European Straw Bale Gathering. It's a biannual festival, and Eileen and Barbara Jones, who are on the stage, were the ones who hosted it in Todmorden. It was successful, absolutely fantastic event over 3 days. And look out for 2025 because that will be in Spain. Go to the next slide, please. So who is here today and who's on the board? There are 4 of us here today. We have Annie Benton, a certified passive house designer and owner of a straw panel home. Julia Bennett, an architect, formerly of Green Register. John Butler, sustainable building consultant. the resident geek, I would say. And Simone Court, who isn't here today, she's our architect, and Simone is our membership secretary. So Annie Benton is our treasurer, Julia Bennett is our secretary, John Butler is our director, and I'm not on that picture, but you can see me. I am the chairperson for Straw Building UK. Next slide, please. So the case for scaling straw construction. So I hope I'm not preaching to converted in saying this. I'm hoping that many of you on this call know next to nothing about straw. And even if you do, it doesn't hurt to really hit home with the benefits, the environmental benefits of straw. What we're offering here, the carbon sequestration potential of straw, the reduction in embodied carbon compared to conventional materials, and by that I mean concrete and steel. There are lower energy requirements for heating and cooling, and that there's a huge benefit for the occupant. And the biodegradability and wasted waste to end of life. So, you know, the circular aspect is hugely significant with this building material. Next slide, please. The economic advantages. You know, this is crucial, isn't it? This is perhaps where we really come down to the hitting the nail on the head. For many people, you know, they want to get profitability if you're building as a construction company, and if you're manufacturing, what you want to do is to ensure that you are making sure that your company is working at a profit too. So for the built environments, there's the cost effectiveness over the building's life cycle. Yes, the potential for local sourcing. You could acquire your straw bales locally. Many of you on this call will no doubt have heard, certainly if you're in the UK, about the farmers having quite a few arguments with the government about their financial position. Well, we would argue we could aid and assist and provide solutions towards that. And in that regard, there's the job creation in the rural areas. Just think about bringing all of those elements together, and obviously the new jobs, that opportunities that come with it. Fundamentally, it boils down to the occupant. So it's the user of the building, whether you're a commercial entity, a public sector entity, or a private homeowner, you will be reducing your energy costs. Next slide, please. The current market status, and what does that mean? So I've provided on the right-hand side here a map. Now, this map points at which the Ecology Building Society allowed us to populate this map with their customers who own straw buildings. Now, I really want to stress this is by no means the finished article, because I would argue that there are several hundred in the country at present. But it's an indication as to where we are with the matter, because the finance sector still has yet to get to grips with the bio-based materials that we are endorsing to build with. And comparatively, if you look at what's happening in France, they're building 500 homes a year, or 500 buildings a year, so private and public sector. Last year, they boasted, quite rightly so, if I was French, I'd be screaming about this from the hilltop, 10,000 buildings were insulated with straw. And they are currently training at a rapid rate as well. They have a course called Pro Palais, and they have had 5,000 professionals go through that. And what we'll come to at a later stage of this presentation is the French rules, of which we are currently translating into English. And the French use that as their Bible for building. Next slide, please. So potential for growth. So obviously we align with what's happening with the UK government's net zero targets. We can boast about that because what we do is natural. Yeah, there's no processing that's involved in this. The consumer, the homeowner, again, as I said, the public sector, they want very much to have sustainable buildings. The opportunities that are there for new build and retrofit markets are huge and significant, and obviously the potential for prefabrication and modern methods of construction are as equally significant, because we do have companies in this country that are manufacturing modern methods of construction, MMC as it's known sometimes, and there is absolutely no reason why this material cannot transition into that. Let's go into the next slide, please. And you're up,
Hi.
John.
So going to try and get through quite a bit quite quickly. I'll try not to garble my words, but if anything isn't clear, feel free to come back at the end and ask questions. So looking at the thermal performance of straw as insulation, essentially it varies slightly depending on the format of the straw essentially. So we're kind of looking at bales. They tend to have a sort of somewhat random orientation of the straw fibers. So kind of the average lambda 9090, which is the thermal conductivity that 90% of samples will achieve 90% of the time. So it's kind of looking at the most accurate results. Kind of average of those from tests of straw bales, you're looking at about 0.065 watts per meter Kelvin thermal conductivity. If the fibers are sort of trending to vertical in the wall, which some bales do, then you're looking at sort of slightly lower, 0.055 or 0.052. With prefab straw-filled panels, it obviously depends on the exact specification of the panel, what the thermal performance is, and what the filling method is, but it's sort of, you're going to be looking at similar sorts of results. Chopped loose straw I can't speak, loose fill straw, you get a lower thermal conductivity because essentially you've got smaller bits, so there's many more little pockets of trapped air, which is what gives you your insulation. So you're looking at kind of more like 0.041 to 0.044. To kind of put that in context, just quickly look at some other insulation materials. Next slide, please. So cellulose fiber, which is essentially chopped up loose fill recycled newspapers, looking at 0.038 to 0.04, so quite similar to the chopped straw, possibly slightly more insulating. Next one, please. And it kind of across the sort of what sort of tend to get called natural materials, although I sort of rail against the word natural slightly, but kind of plant-based and similar materials, you're looking at kind of between 0.036 usually and 0.04 something. So they're all kind of occupying that kind of similar ground. Thank you. So yeah, looking at expanded polystyrene, it's actually a similar sort of range. It does go down a little bit lower. 0.034 is slightly more insulating. Mineral wool, again, sort of occupying that same kind of thermal conductivity range as the chopped straw, but with potential to go more insulating depending on the density and the fineness of the fibers. PIR is obviously one of the most insulation materials we've got at the moment, right down to 0.018. But I'll look at the environmental performances of these compared to straw next. In fact, next slide, please. So to look at the environmental impact of straw, we got the first environmental product in declaration for straw. And so that's a UK-wide one. It's based on UK data for sort of all the impacts that go into growing the grain. The proportion of that's allocated to straw is based on the economic value of straw versus grain. So it's crucially, it's sometimes called a waste product, but I think it's important to distinguish it as a co-product. It's still a product that's straw itself is still a product that has value, and we're potentially adding value to that. Eco-Cocon straw panels now also have an EPD. Next slide, please. So this is looking at the kind of carbon emissions per meter square of insulation for each of those different insulations on the chart, crucially adjusted. So as they've all got slightly different thermal performance, thermal conductivities, sorry, you'll need different thickness to achieve the same thermal performance. So this is the carbon emissions with the thicknesses adjusted to achieve an R value of 3. You can see that the two with the lowest carbon emissions are straw and cellulose fiber. Cellulose is only lower because it's a recycled material, so you're only looking at the emissions of processing that. for cellulose fiber sort of made of new material, which is essentially what kind of loose fill wood fiber is, you're looking at the sort of third, it'd be similar to the hemp jute fiber one, that third bar from the left. So straw and cellulose, very much the lowest carbon, EPS and PIR definitely coming out the highest carbon. Next slide, please. So this is environmental product declarations look at a whole range of environmental impact indicators, so potential environmental harm, essentially. This is a crude measure of just aggregating all those measures together, and it doesn't account for the fact that a tiny difference in one of those might be more harmful than a bigger difference in another one. But to give a general overview of the kind of environmental impact, I think it's quite a useful first look, and then you can dive into more detail on the EPDs. But clearly, again, straw and cellulose fiber coming out very well there. Straw is by far and away the lower, well, marginally lower overall impact than cellulose fiber. Essentially, straw is cellulose fiber with some other materials. It's just in a different format. PIR board not looking great on overall impact. So this is the kind of trade-off. You've got the lower insulation value of those materials, but when you adjust, even adjusting for the fact that you need more straw than you do with PIR to get the same thermal performance, the environmental impact of straw is still much lower. Next slide, please. Also with straw, you're storing a lot of carbon. So all the plant-based insulation materials during their growth cycle store CO2 from the atmosphere during the photosynthesis. They store that in the plant material. At the end of the growing cycle, if that straw is, in the case of straw, if it's kind of used as bedding or used as incinerated to generate heat or power, all that carbon is released. If it's composted, it's released. So generally, the kind of carbon from straw would be released within a few years. If you take that straw and keep it in a building, you're keeping that stored carbon out of the building for the lifetime of that building, and the straw will last for the lifetime of your building, basically. So unless you decide to knock your building down, that straw and that carbon remains out of the atmosphere. And again, looking at sort of the impact per meter square with the thicknesses adjusted for the different thermal performance, you can see straw is storing much more carbon than any of the other materials. So it's providing a useful buffering effect. Eventually that carbon will be released, but potentially not for kind of however long your house lasts, which the existing straw buildings have lasted for well over 100 years so far. So it's looking good for keeping it stored. Next slide, please. And what about measured results for thermal insulation? This is actually from some research by Annie, who's be talking shortly. Oddly, I've ended up talking about her research, but Annie measured the U values of the straw, the EcoCon straw panel house that she lives in, and compared that to the kind of calculated U value. This was over 3 weeks in January, so it's kind of a good test at the cold time of year. On the left bar is the calculated U value. On the right is the average measured over those 3 weeks. It's slightly higher, but the kind of margin of error is 13%, so that sort of brings it potentially back in line. It might be a bit worse, it might be a bit better, but it's pretty close, is the kind of gist of that one. Next slide, please. Moisture is another thing people worry about a lot with straw, understandably, but in fact, it's not usually a problem. In order to decay, straw needs persistent moisture content at 25% above. During a very high rainfall year, I think at Modsell as they were then, and the University of Bath monitored the moisture levels within straw bale walls in Bath, and found that the maximum they peaked out was 21%. So that's staying in the safe zone. And this chart on the left, each of those sort of wiggly lines is a different sensor in Fran Bradshaw's straw bale house in Norfolk, starting with just post-construction. The sort of darker pink area at the top of the chart is the kind of danger zone, essentially. If any of those lines go into there, then the moisture content is above 25%, where rot can happen. But even at the construction point where you've had lots of wet plastering, lots of mortar kind of put into the building, they're well below the sort of the zone where decay can happen, proving that it's good and safe. Next slide, please. Fire resistance is another thing people ask about a lot with straw. There's now been quite a lot of tests, sort of formal certification tests of various different versions of straw walls and straw panels for fire resistance, which is how long they will contain fire. Generally, these are sort of stopped at kind of between 2 hours and 2 hours and a quarter, because continuing the test at that point is really expensive, and essentially there's no benefit because they've already exceeded all the regulations in the EU and UK for how long you need to contain them. Those two photos on the right sort of show the test. So what you can't see is on the left-hand photo, the backside of that wall is plastered and is in a furnace at sort of 1,000 degrees. The image on the right is after you dismantle that wall at the end of the test. Those timbers which were set in the middle of the straw are clearly still timbers. They're well protected. Only the very outer edge of the straw has charred over that 2-hour test. Reaction to fire, which is sort of spread of flame, you're looking at a kind of B rating. So A is obviously completely no contribution to combustion. B is potentially slight contribution. S1 means no smoke. D means no sort of flaming droplets, bits dropping off your wall. So currently that would exclude it from use in the UK on buildings taller than 18 meters, but otherwise it's a very good fire rating. Next slide, please, which I think is my last. So yeah, a lot of this information is in the straw construction in the UK technical guide, which brings together a lot of the info you might need for building regs. It also has information for structural engineers, which you can then use for their calculations for building regs. So use the guide and the appendices as evidence for building control, and you can find it via our website. And I'll hand over to, I think it's Julia next.
It is. Thanks very much, John. Thanks everybody for joining us today. So I'm going to do a quick whistle-stop tour through some of the architectural implications of straw, or opportunities. So the design principles, we start really with structure, don't we? So we have three rough categories for how we hold up straw buildings. The picture on the right-hand side shows load-bearing straw, where straw is the insulation material, but it's also the structure. Tends to be single-story buildings, very often accessible for self-build. This is a forest shed for training out in the forest, and the people who are going to be working in the forest are actually building it themselves. And there are quite a lot of self-build projects in the UK where this type has been used. The second type would be an infill or hybrid. So you're introducing a traditional timber frame in many ways, and you're using straw bales or straw sections as the insulation material. So the straw is not carrying the load. It's a timber framed structure. And then, as we noted before, we now have the equivalent of SIPS panels, structurally insulated panels, but the insulation material is straw. And we'll see some more pictures of those as we go along. So the integration with modern building methods is right there. It's right there, available on the market right now. And that's quite exciting, because that's probably the area where we're going to be pulled into the mainstream more and more. And I'm going to show you some pictures shortly of the flexibility. There's absolutely no reason that any of this, the fact that it's a bio-based material, causes very much constraint at all on people's architectural imagination. Every material has its constraints. Straw is no different than that, but I'll show you some images of just how far you can go. Next slide, thank you. So this is a picture just showing the principles of the load-bearing straw. So you can see that bales are stacked up in a brick bond kind of arrangement, so that it's spreading the load and you've not got constant gaps going down. You start off with a timber base plate called the sill in this diagram. And then on top of the first story of straw, you would have an intermediate plate, a wall plate. And in this picture, it's the wall plate that is carrying the roof structure. Foundation is something we'll come to later. And the most, in our climate, the most sensible thing to do with straw is to apply an external hopefully lime or clay plaster. And that is a weatherproofing coat, as well as providing a wind coating for the insulation, so that we're not having heat loss through air movement. Next slide. Here are some pictures of infill construction. You can see a traditional timber stud frame. It's actually sometimes a two-post in order to cater for the thickness of the bales. They are persuaded in between the studs, and on the left-hand side you can see a wall that is almost ready for its first coat of render. It gets very tidied up, and using a chainsaw usually, or smaller tools sometimes, to get that very smooth finish. But that shows you the principle. Next. And this just shows you what the insulated panel system looks like. These are pictures of EcoCocon on the left, and a mod cell. It's a detail of a mod cell building with a truth window in it. People quite often like to be able to put a hole in the timber paneling or the render, so that people can see that it really is straw in the wall. So there are lots of out-of-date perceptions, and we all know the Three Little Pigs story comes up again and again for us board members and people that are impassioned by straw building. But really, we've gone way beyond that. So top left in the pictures is the passive house in Herefordshire using EcoCocon. And George had to take out his wood-burning stove because it was too hot. So they had to throw open the windows and doors even in snowy weather like we've just had. So this is how cozy it gets. Then top right, that is the Hastings Visitor Centre that Cypren mentioned earlier, one of the upstraw projects that was built in the UK. Bottom left is Nottingham University building called Gateway, and bottom right is Agile comes from the same people as ModCell, and they are trying to develop these modular, affordable prototypes, trying to make sure that there is product on the mass market that is like in kit form, but is straw insulated. Next. So the contemporary design examples I'm going to show you some more of. This project is probably quite familiar. It's in Leeds. It's a co-housing project. One of the things is that, as I said before, there's not really any reason why straw can limit your architectural imagination. People often feel that that's going to be one of the constraints when they've seen sort of round houses with turf roofs. Those are gorgeous in their own way, but as you can see, this is it's an award-winning contemporary building, and it's affordable housing. So that's also something important to mention. On the aspect of planning approval, again, planning has very specific elements that it relates to, that it's allowed, that are allowed to be considered. And most of them are about scale and location and appearance, sometimes the material palette. But again, what straw buildings look like are not necessarily limited by the fact that they're using straw as their insulation material. So the completely uninitiated would look at this project in the picture and they wouldn't necessarily know it was a straw insulated development. And then straw also presents opportunities for innovation. John's already mentioned about how low the embodied carbon is, and it challenges us to come up with more and more innovative detailing, and I'll show you some examples of that. But also it's moving mainstream construction to take on the idea of bio-based materials, especially the fact that it is abundantly available in the UK, where so many of our materials are coming from other countries. So this is something that we actually don't rely on others for. And next slide, I'll see if I can speed up a little bit. So here are some details on the left-hand side that come from the Strawworks website. They're freely available and they're noted and actually included in the technical guide that John mentioned. So part of the innovation, if we're trying to look at very low embodied carbon buildings, we're trying to remove concrete, especially in foundation design. We're definitely removing steel where we possibly can. and we're trying to limit the amount of glass. These are the high embodied energy materials that modern construction often uses. So this is a very quick glance at two different options for low height straw bale buildings. On the left hand side, with those funny hoop shapes, this is a detail for using old car tires as a foundation. So you dig a pit, you put some very compacted pebbles in the bottom, gravel, and then you put a car tire in and you fill that with gravel, pea gravel, and then you keep on building it up to the height that you need. And believe it or not, it becomes extremely stable. Some people use a little bit of steel to spike down through to stabilize it. But this is actually being used in projects that are not only self-build, but there's a project in London that was a huge church hall that used exactly this detail. And then the one in the middle is, again, it's using a masonry plinth for the straw bale wall. So you can see a cavity in the middle. It's a little bit faint. If you've got a small screen, that might be pushing you to the limits of what you can see. But the significant thing is that this has no concrete underneath the cavity wall that is the plinth for the straw bale. And this has been accepted by building control in several areas. So building control, as we all know, it just depends which officer you get. But very often, if they can see that there are technical details that have been approved in other places, it helps your case. And then on the right-hand side, what I'm showing you there is a 7-story modular straw insulated building. And that's just to show you that we're not just talking about single-story buildings. We're talking about modern, mainstream potential. Next slide. So the sectors in which straw is coming through, it started out with the pioneers and the residential one-offs, as you would expect. Most new things come through that way. Then it has moved into, as we saw, residential multi-unit that are commercial offices, warehouses, community buildings, one-offs like the visitor centre we saw, and it is now coming through as an external wall insulation material, which is something that John knows a lot more about than I do, and it will be the subject of a talk another time. And not very far off in the UK, we are looking at developer housing and schools, and no doubt it will expand into other things. As Cypren said earlier, France is way ahead of us on this. They have regulations now that require people to consider bio-based materials as their first port of call for developments. They must prove that they've looked at bio-based materials, and that is why they have so many straw bale projects, and why the training of professionals is developing so quickly. Next, please. I think we just have some really good pictures of how unconstrained the architecture can be. So this is just a rural cabin project in Austria. It's made from completely locally sourced materials because it's in the middle of the countryside. And again, coming back to the idea of no concrete foundations, the whole building is supported on 8 ground screws, which are just metal screws that go down into the ground with a beam around the top of them that supports the walls. Next, please. Here is a house in the UK that was self-built by a structural engineer who'd lived in a barn in Kent, a cruck barn, and decided that he could probably come up with a design when he bought a piece of land in Cumbria that would give him the same spatial experience but might be using straw bales. So he made these beautiful cruck frames out of timber, and the little tiny section that you can see, it's sort of on the left-hand side, you can probably just about see the modules of the bales going up the curve. And I think he said out of 360 bales that he used for this project, he only had to cut 1 or 2 to size. So he'd modulated it so that none of the bales were actually used in their almost unprocessed state. Next, please. This one's in Italy. It's a rather smart one. It's an award-winning project. It is made almost exclusively from straw, wood, and cork. So the insulation material is straw. The structural material is wood. And that cladding on the outside is cork, which is fascinating. I've never seen cork used in that way. And it might not suit the UK climate, but it does look rather beautiful. And if you like minimalist architecture, it's completely different than the shaggy, hairy kind of perception that some people have of straw bale buildings, which is why I've put it in there. And I think the next one I'm showing you next, Annie. Yeah, this one is just going to blow your mind. This is a concept, an award-winning concept from a competition for a secondary school in Lake Malawi. It used, again, local materials. It was a modular timber structure. And you can see they've stepped the bales within, again, A-frames of timber. And if you look at the little picture, I wish slides were bigger sometimes, but you can see the internal environment of that classroom. Looks absolutely gorgeous, doesn't it? The quality of the light, even the way that they've brought the furniture through. It would be an absolute dream to teach in that space. And because of the climate in Malawi, what they actually have at the very top of that section is gaps in the structure, and that is where the natural ventilation flows. Let's see if I think that might be, yes, that's my last one. Sorry, Annie, I've taken too long.
No, that was beautiful. It's so inspiring, isn't it? Seeing how versatile it is as a material. So no, they're beautiful, lovely images. So hi everybody, thank you for joining us. I'm just going to sort of talk a little bit more specifically about panels. I'm a bit biased because I live in an Ecocon straw panel house that my late dad designed and then built, and then we came together in the end as a family to get it done. And it's just a beautiful building to live in. As John said, he shared some of my data for my dissertation. I just finished my dissertation at CAT, the Centre of Alternative Technology in Wales, and I measured the U value in situ using the British standard 9869, using heat flux pads. So yes, I just thought I'd talk to you. There's some real benefits of it for future of straw. So I don't think we're ever going to lose the bales, particularly as self-builders. It's a very affordable material and also very accessible and easy to use. But panels are possibly coming forward as more of a future consistent building material, if you like. So they're very good in either residential or commercial for a solution for building. They're going to meet all sorts of needs of volumetric house builders and also for social housing, as we've seen a few projects Julia spoke about already. What's really important and crucial is the speed of either, well, speed of getting them in straw into the actual wooden panels, but also the speed of build. So our house is 180 metre square double story, and the panels arrived on 2 lorries and were put up in about 4 days with a team of about 4 or 5 guys. So, you know, amazing speed at which a building is built, which I think is really important. And also you get the factory efficiency. So things match up, things fit. There's no having to bodge job. You're not wasting materials on site by cutting things to fit. Everything's designed digitally, effectively. So as I've said on my slides there, we've got Q&A as well. So you've got that quality assurance, as well as providing all the technical information, because it's manufactured in a factory. It has to meet the regs and all of that's provided. So you get much more consistency. These products are from Ecocon. So there are other panelized companies in the UK and also across Europe. It's much more commonplace in Europe. So this is actually unusual in the UK, but very, very common there in Europe. So Ecocon is the ones we've got, but there are others. Ecocon panels are Passive House certified as well, which is really helpful. There is consistent performance in the straw, as John was saying. You know, bales can vary in their density and their type of straw and the orientation, etc., which can impact thermal performance. With the panels, you get a much more consistent thermal performance, which I think is great. It's going to reduce that performance gap that we have in construction, which you saw from my dissertation results. It's similar. The measured is as similar as predicted, which is really good. Another really great thing as well, Julia sort of touched on, is the structural aspect. So these panels are structural. You can see they're surrounded in ply boxes, and when they're designed with Ecocon, all the structural calcs are completed. So what you get is something that doesn't need additional support. If you want to put additional support in, that's obviously up to design aspect, but it's not necessary. As I've said, obviously it's off-site manufacture, it's less waste. It's also a lot less mess on site. I mean, straw mess actually isn't so bad, but compared to other construction site wastes and messes, but it's nice that there isn't really much of it. And also it can be made to look like normal or standard construction, if you like. And we really need to get away from this sort of hippified view of straw as a building material and bring it into, you know, a really modern method, because it can make beautiful buildings. If you go to sort of Lithuania, you see where Ekikon sort of originated from, and you see the buildings there, they are all look like they've just been gypsum plastered. You know, they don't look like it's lime and clay. It doesn't look like it's straw. So I think that's a really important thing to focus on. An image just on the screen here, just talking about the build-up of panelized straw. So you've got your 400 wide panel. This is Ekikon, how they do it. You then have a breather membrane, and then you have a wood fiberboard, a rigid wood fiberboard that wraps around the outside. You then need render on the outside and then clay plaster on the inside. So it's quite a thick build-up, sort of 470, 480 mil thick. The air tightness is done with the clay plaster internally and the breather membrane here, number 2, that's wrapping around the straw. So you get your wind tightness and air tightness that Julia was talking about, to make sure that you get your really good thermal performance, because it isn't just about insulation. It's about trying to stop those air leaks, keep that building away from drafts. Obviously you need a ventilation system. We have a MVHR, so mechanical ventilation with heat recovery. And I can't, that's just such an amazing system to live with. So I really recommend it if anyone's thinking about having one and they want to talk about it. It's so worth it. So this is just a little picture of the panel projects. If you wanted to design a building with Ekikon, or Modulina is another brand, another company, you sort of design a panel project like this and they sort of send you all the information, and then all the panels come all in the right order on the lorries, and then they just pop up with all the instruction guidance provided by Ekikon. It's really thorough. And this is sort of what the house looks like finished. As you can see, it's rendered on the outside, so it could be, you know, it is lime, but it wouldn't have to be. It looks like it's modern. It's not necessarily a hippified building. So that is our finished building. These are just sort of supporting what Julia said. Other examples. So Old Holloway is also Ekikon. This is Passive House certified. Our house met Passive House was designed with PHBP, and it meets most of the criteria. We were just slightly missed the air change, but my dad wasn't really interested in getting it certified. He just wanted it to be designed by Passive House principles and then it to perform, which it does. So we're very grateful that he decided to choose that. This is just a sort of shout out to a UK-based company, Agile Homes, or ModCell, that Julia and I think also John's referred to. It's worth checking their website out. They've sort of rebranded over the last couple of years, and they're really promoting panels made from renewable materials, not just straw. So I think really interesting following them on social media and having a little look at their website and their products, and going have a chat, and just something to look at and research more about. So scaling and a few sort of considerations to think about how we can make straw more mainstream. I mean, we have straw across the UK as surplus. It would be really worth evaluating that volume and looking at its use and its waste to see the material. I mean, John did some of these calculations a couple of years ago to work out, I think it was like we could build, was it 43,000 homes? I'm not sure, John, with the surplus straw, something like that a year. But it'd be worth looking regionally. You know, what do we have regionally to us? What would we have less miles in transport? I do think we need investment into factories, and we need modern method of construction factories to actually adopt straw. I think that's probably one of the most efficient ways of doing it, rather than starting a whole new process. But we do need to industrialize it, and we need to seek advice from people who know how to do that. It's something we don't necessarily have a knowledge of on our board, and it's something that we probably need to reach out to and find more out about so that we can guide people. We need to make sure we've got farmers on board, and actually I'm in East Anglia, and we've got actually farmers that are really keen to be involved. And see the real importance of it, which is great. France, we had a webinar a couple of weeks or last month, and we spoke to a member of sort of a colleague in France, and she referred to the fact that in France they've created this ecosystem for straw to be like pivotal in construction. And I feel like that's exactly what we need to do in the UK, which we haven't quite done yet, which we need to master. And part of that ecosystem is farmers and building companies, upskilling them, but it's also education. You know, France have the most phenomenal training courses, but I also think it needs to get in the UK. We need to filter it down into FE and higher education colleges, right down, so that they don't think it's unusual. And I think that's a case of working with colleges and trying to get more employers, building companies on board, you know, awareness and that sort of thing. That all needs to happen. I think as well, the plans and designs, Julia said, you know, Strawworks have design details, but it's about pushing and promoting that. And I think as an organisation, we need to do that better as well, making that easier accessible. so people can get those design details and talk to each other about designing with straw. Again, we keep referring to France, and that's because they're just epic and they've just done so many amazing things and it's really working. So I think learning from Europe and generally raising like awareness, drum up demand. And my last sort of just things, just sort of to summarize, I've touched on a little bit of these things, but I think some of the major opportunities and challenges with straw. So we know that straw meets all building regulations. In our technical guide, which is freely available, it ticks all those boxes. Challenge we have is supporting building control on site with understanding how straw works, not to be afraid of it, not to worry. And I think panels make that a lot easier because of the technical information from manufacturer. You don't have the variety of varied straw. You've got it more as a consistent approach. I think it's really positive in the UK. We've got the Future Home Standard and we've had the consultations, and people from the built environment have come forward and their comments have been really promising about pushing government to look at embodied carbon in materials. And I think that's a really amazing thing to read. As someone who works in the built environment, that's really positive. We don't have any legislation in it technically yet. Even the net zero carbon building standard has it as an extra, but it's there. And I think that's a real opportunity. Challenge is to try and keep pushing government, trying to get embodied carbon as a metric. And the sort of last opportunity and possibly challenge at the same time is trying to upskill an existing construction workforce without them having to lose work being upskilled. So we don't need to take them off sites when they're meant to be earning, something needs to be worked out in that respect and trying to change its perception. But I think that comes from these sort of webinars, more awareness, more getting into colleges and education, more contacting companies, all that sort of thing, and having open days of buildings as well so people can come and feel it. And see what these buildings feel like and have a sort of an emotional connection. So a whistle stop tour there, but I'm just conscious of time. So yeah, over to you, Cypren.
Thank you, Annie. Thank you, John. And thank you, Julia. Wow, that was phenomenal. That was brilliant. And you wonder why these people are on the board. Simone Court, who's here today, she is also on our board. Qualified architect. We have the best team available for this to make it happen. So Straw Bale UK's, or Straw Bale Building UK's vision and strategic initiatives, what are they and what do they amount to? So when I consider the projected growth in the market share, the figure that Annie gave earlier regarding the 5% of our yield in this country, the wheat straw yield in this country, is just absolutely fundamental to where we're getting to, because what we're saying is that this is just going to be a minimum. And if you consider that over a government's term, we could build 194,000 homes, right? 194,000 homes. That's a phenomenal figure. But of course, this does depend on several aspects, right? So the model assumes a rapid but achievable industry growth, development of supply chain and skills base, just as Annie and others have said, an increase of the prefabrication capacity, growing market acceptance and support from planning authorities. Yeah. Next slide, please. And in addition to all of that, the job creation and the job opportunities that come with it, there are the collaborative aspects regarding the education bodies. So we really need to have much more detail at our higher education and further education establishments. The partnerships with major construction firms, the big developers, that really needs to happen. We need to be talking on those tables with those people. The engagement with policymakers for supportive legislation, in turn, that needs to happen at a greater depth. The images that you see here are I've teased you somewhat with the new build on the right-hand side in Sweden, and of myself at the bottom with a European straw building delegation. This year, we visited the EU Commission and discussed with them about the possibilities about broadening the promotion of straw building. Next slide, please. So, as I said, I teased you a moment ago with that building. This is being constructed at the moment. On the right-hand side, you can see what's going on there. And on the left-hand side, the drawings and the detail. It is going to be the tallest straw building in the world. The companies at the bottom you can see are EcoCocon, Kaminsky, ETC, Big. They are European organizations. 52 apartments will be housed within that. It's in Malmo in Sweden. And look at EcoCocon, Kaminsky, and ETC's Big's websites for further detail. So the potential is there, and we can do this in the UK. If they can do it there, we're on the same continent, it's very possible. Next slide, please. So just to close, become a member of Straw Bale UK. Thank you very much. We're open now for questions. We are members of Straw Bale Building, the European Straw Bale Building Association, and equally members of the Alliance of Sustainable Building Products. If you become members of us, you are members of those organizations, which enable you to get in touch with the network and really put your hands on the courses and or the talks and networking opportunities. Go to our website and join us today. That's the end, Simon.
Brilliant. Thank you, Cypren. That's fantastic. Thanks, guys. Really so much information there. And I appreciate how much you've packed in, and you've done it in a very timely manner. So it's marvelous. And just following on from what everyone said, Anu, at the end, was like very inspirational examples of how to use straw. And it was interesting to see that they're not these hippified buildings, and it's like, how do we actually get more people to use it? So I thought it was a fantastic webinar. Thank you very much. John's just been going through some of the questions that we've had on the chat. I'm just conscious of the time. John's addressed Patrick's point about sort of the lifetime of insulation using with straw. Rob asked, in order to try and secure the use of straw and convince clients and builders to use it, would it be great if there's, so he's talking about evidence around advantages in terms of human well-being. Well, I know that's on your website as well, isn't it, Cypren, in terms of, obviously it's a natural material or bio-based material, so you don't have the after effects of you would from traditional man-made solutions. Does anyone want to add anything to that? I mean, Annie, you're living in a straw-built house. How is it? I bet you're warm.
Yeah, it's fabulous. Do it.
Yeah.
Yeah, I mean, it's like natural materials have great hygroscopic properties, so they naturally want to buffer moisture, and also clay plasters are just known for being able to sort of make air beautiful. Like, you know, there's lots of research. I mean, probably needs to be more research, but from living in one, it's beautiful. I mean, I'm biased because we have the MVHR, so that ventilation system is really helping to make the internal environment lovely, and it's taking out horrible air and it's putting in fresh air. So I think that also really helps. But yeah, I mean, it feels like you're having a great big hug when you go in there. And when you change the filters of the MVHR, you really realize how many particulates are actually in outside air as well. So it's kind of, it makes you really acutely aware of your indoor environment. So it's a very pleasant place to live. Yeah.
Cool. Thank you. Neil made a point around hemp and jute, but John's addressed that. Sorry, 2 seconds. Mona's asked a couple of questions. If we compare building with SIPs and building with straw boards, which would be more expensive? Or is it depending on a project by project?
I think it does. I think there hasn't. I don't think there's been a recent comparative estimate. It's a good question. It would be something that would be useful for us to investigate and put on the website.
Cool.
Yeah, I mean, our building, I just thinking this is helpful or not. I mean, it's 180 meters squared. It did have my dad's, up until when he was really poorly, sort of self-build labor. We have to employ people too. To finish that cost about 280 to 300,000 full turnkey. So, and that's full as everything. So it turns out it works out to be like 1,600, 1,700 quid per meter square, including the panels. And I think actually the panels have actually reduced it. When I asked Barbara to cost it for Future Build Talk that I did last year, I think they actually came out cheaper than they had when my parents actually bought the panels in 2017, which is interesting. So it's, I mean, watch this space. I think EcoCon have just upped their factory in Slovakia now. They've got more manufacturing space. So it'd be really interesting to see this and monitor it as it goes forward.
That
cost.
that tallest building in the world is actually cheaper than the conventional, if it was built conventionally in Sweden.
It's amazing, isn't it?
It is.
And then in terms of, I mean, this is a question that I always ask. And sorry, I'm just trying to find it. It might have been Julia. Sorry, there's a bunch of questions here. Essentially around, oh, it's sort of Deb's, and if she's talking about the support, because you gave all the examples of the properties that are currently been funded or they've been built out using straw, and obviously you've done the fire test. It's a Building Safety Act that's obviously going to have an impact. But when it comes to the Ecological Building Society, I mean, and scaling out, where are we with the mortgage providers? Obviously, these buildings exist and they're fantastic. So
Yeah.
what is
I'll answer that
the
one.
hold up?
I'll answer that one. What we're finding is that and have found over the years is that it's not that the mortgage providers or insurers, for that matter, are skeptical about the process and the material, and especially the concerns around fire safety. It's just that they are governed by what we have in terms of regulation, right? So they're very open to seeing what's moving forward. And at the moment, we as a group have working groups to mitigate and look at all of these factors, all of these, whether it's building regulations, finance, and we're presently looking at that particular aspect too. It's positive, it's not negative, and I think the opportunities there at the moment for the finance sector are significant, to say the least.
Yeah, yeah. I know, and I know there's a even within Mesh Energy, our founder Doug, he's in high level talks just with a funder who's looking to collate investment funds for sustainable projects, at a very high level. So yeah, I mean the potential here is huge. I'm conscious now 1 o'clock, so I'd just like to say thanks for everyone for attending today. It's been really engaged, been really informative. Thanks to you guys on the call for delivering such a fantastic presentation. It's been really, really marvelous. And I'll put a recording of this out because people join late as well. So, there'll be a recording that will go out on Meshwork today or tomorrow as well. So I'll share that with you guys. But no, it's been really, really interesting about hearing about straw as an installation. If any of you would like to come on for a future webinar and talk about something else, another topic would be absolutely fantastic as well. So, got a great group of minds there. So no, appreciate it. Enjoy your afternoons and speak soon. Cheers, guys.
Thank you, Simon. Thank you.
Cheers.
Thanks for having us.
Bye.
Bye.
Bye.